So we're navigating over here to our Jupyter Notebook. Keep in mind that you have lessons and you also have solutions. So if you want to follow along with the solutions code, it's all available here in Dictionaries. But I'll be working in the blank notebook. And I'm going to put this up on full screen. Okay, so up until now, we've been learning about sequences in Python. We've seen that a string is a sequence. We've seen that a list is a sequence. A step even further than that is a mapping, where we have a series of keys and we link them or map them to a series of values. This key value mapping is familiar to anybody who has used an API, or has used a JSON file, or has used a NoSQL database such as DynamoDB. It's a very common structure in any contemporary or modern data structuring type, and Python is certainly at the forefront of all of that with its dictionary object type. In this notebook, we'll talk about constructing a dictionary, how to access or find objects inside of a dictionary, nesting them, and then a few basic dictionary methods, and end with you building out your own dictionary, first guided and then on your own. So let's build a few. And this is unnecessary, it's just a useless cell. Okay, so a dictionary is indicated by curly brackets, just as a list was indicated by square brackets. A very simple dictionary would look like the following. I'm going to call my dictionary Webster. I could have named it anything, right? I could have named it, I don't know, my dictionary, or I could have named it my favorite dictionary, or something like that. Webster's just a good name for dictionary. What you cannot name it is you cannot name it DICT. Notice how that defaults to green. That's actually a built-in Python command for turning something into a dictionary. So give it a name other than that. Webster is, I think, a strong choice. And inside of brackets, we type in key1 colon value 1. This reads kind of like one of those old SAT questions where key1 is to value 1 as perhaps key 2 is to value 2, right? That's the basic idea of a dictionary. A key followed by a value, a second key followed by a second value, a third key followed by a third value, and so on and so forth. It's kind of similar to a sequence because every sequence had an index. If you remember, my list, which I'm going to name Franz, right? My list looked something like this. Blue, 1, 2, false, right? This was a list of values, and each of those values, Franz.index, or Franz. Let's do 0, right? Each of those values in the list had an index, 0, 1, 2, 3, and we even learned to nest a list with a second list, list 1 and thing 2, something like that, right? Maybe the fifth one in this is that. Oh, we don't have one, so it's out of range 4. So each of these was a value, and each of the values had an index, which was always numerical. What's nice about dictionaries is they also have a series of values followed by something similar to an index, but the index is non-numerical. The index can be a string, or a number, or a Boolean. It can basically be anything. And what's nice about this, what's extremely powerful about this, is that the keys are not ordered. A list is always ordered. It has an index starting at 0 and going up to infinity, and the list items must always proceed in that order. But dictionaries are completely non-sequential, and as a result, you can add things to it anywhere, and you're not messing up the order. Put another way, suppose you had a list of users for your website, right? and you had them structured in a certain sequence, maybe alphabetical or something like that, every time a new user comes in, if you were using an index, you'd have to go and find exactly what was the correct index and kind of insert the new guy in there in the right spot. But if you give each of your users a non-ordered key, it's much easier to insert new members because it doesn't matter where he is. You can still search for him using the key. But it doesn't have to be any, you don't have to maintain any order to it. Okay, so we've made a dictionary and we've compared it to a list. And I'll just put a note in here, compare to a list. Indexes are kind of like keys, but ordering. Okay, something like that. And we can call values by their key. So if I call back Webster, it looks like, whoops, I didn't actually run that cell. Webster's there. Call back Webster, it looks like this. And I can call Webster by key 2, and it only gives me back value 2. So notice this is similar to Franz, right? I called Franz index 4, and I got list 1 thing 2. I call Webster key 2, and it brings back value 2. As said, noted here, it is important to note that dictionaries are very flexible in the data types they can hold. For example, Webster 2 might be the following dictionary. And here I'm going to rename my keys as colors so that you can see that a key can be anything. Blue, or perhaps blue key. Yeah, let's just go with yellow key. It's going to be 1, 2, 3. Red key is going to be a list 12, 33, 34. Orange key is going to be a Boolean, true, and yellow key is going to be a string. String, there we go, string. So how do I get back only the word true and nothing else? What would I type? Get back true. You would type Webster 2 brackets for calling the key orange key. When I run that, I get back the value because that's the key and it produces the value. Let's call a few other items from the dictionary. What if I wanted to get 1, 2, 3? I would call in Webster 2 blue key, and it would give me back 1, 2, 3. But, whoops, that's not going to work because it's not a list. Red key is a list. Okay. Webster 2 red key was a list of 12, 33, 34. And as we know, lists have indexes. So I'm going to copy this code, paste it here, and if I only want to get back the number 33, what do I type?
1.
Exactly, index 1. Because this is a list of index 0, 1, 2. So dictionary name, key name, index. And I can do something similar with yellow key because it's a string. Webster 2 yellow key 3 will give me back the letter T because it's 0, 1, 2, 3. And you can even call methods on that. Keep in mind that we could have done 3 that. We could have gotten string, and the method would be upper. And it converts string into uppercase because this is a string with a method that's a string method dot upper that we saw in the string section. Okay, you can even affect the values of a key. So we have Webster 2, what was red key? Red key was our list. Actually, let's go with the first one, which is a number 1, 2, 3 was blue key. and we can subtract that. Blue key minus 10 is 113. And if I want to, I can reset that value or create a new key, maybe purple key. Purple key is equal to blue key minus 10. And as it says here, you could subtract 123 from that value. Minus 123 is going to be a negative 10. So all kinds of things you can do with dictionaries. It's a great way for storing data. I'm not sure what the word check is in there for. I'm going to delete it. Python has a built-in method of doing self-subtraction or addition. By the way, this is kind of separate from dictionaries, but kind of nice to know. Since we had that code, an object to itself minus 123, if I add an equal sign in here, it will reassign that value to purple key. So I run that, and now I call purple key, and we'll see that the value has changed. Now purple key is in fact equal to. So this minus equal is kind of a nice Python shortcut for redefining any variable as itself minus a number. Okay, let's stop there for a second. We can also create keys by assignment. Before we get into that, before we get into nesting, let's go ahead and wrap this up, and then I'll have you build out your own dictionary. We can also create keys by assignment. So let's create a new dictionary called Webster 3, and it's blank. And if I call it back, Webster 3, it's just blank. I can create new keys as follows. Webster 3, I'm going to give it a key called animal. Is equal to, or animals maybe, is equal to a list. Dogs, cats, parrots, mice. And now when I call Webster 3, it's no longer blank. If I want to add another key, I can add one called numbers. And this is going to be a list of 12, 45, 22, 25. Now when I call Webster 3, it's going to have two keys, animals and numbers. First is a list of strings. The second is a list of digits. And when we built one of our earlier apps for deploying on Heroku, you might remember that the bar chart was a dictionary like this. It had a list of X values, which I think were the names of the beers, and a list of Y values, which were the numbers associated with IBU and ABV. That was a great example of using a Python dictionary in action to create a working app and visualization. And finally, Webster 3, numbers, and we'll just call one element of it. Let's call element 3, would be 25. But animals 3, so let's print these together, print that, copy that. Animals 3 would be mice. And maybe if I'd like to pair that, I can create a new list, and I'm going to set it equal to Webster 3 numbers and Webster 3 animals. Put a comma in between the two of them. Call new list. And it's equal to mice. So I've got 25 mice. And I've got 45 cats and 22 parrots, whatever the association is. This is a way to combine dictionary elements into something new. All right, let me pause there. Turn it over to you to just take a second to try and build out your own example dictionary. And once you've done it and you've successfully displayed it, post your output in Slack. can post here in the General tab. Nice use of a for loop, Max. Excellent. Okay, hoping for a few more posts here in Slack before I move on. Megan, I love the way you built this sentence out by concatenating strings. Can you do this again, but use an F string? or formatted string. Great. Just as a quick example of using formatted string, maybe you'd like to do something like this. I saw some in the cellar. Remember, you put the F prior to it, and then inside the brackets, choose the value of the dictionary because, of course, it's a question of single versus double quotes. And there we go. Okay, nesting with dictionaries. So you can have dictionaries inside of dictionaries inside of dictionaries, just as you can also have, as a reminder, lists inside of lists, right? So I think I defined Franz earlier, right? And now we can put a Mozart is going to be musicians, comma, Franz. And we saw that Mozart 1 gave us Franz, and Mozart 0, 1, 2, 3, 4 gave us list 1 and thing 2, and 1 gave us just thing 2. So this was a way of calling, and I'll type in what I'm saying here, using an index to call elements of a list. That's review of what we did on Tuesday night's class. Well, we're going to do something similar with nested dictionaries, but instead of using index numbers, we'll use keys. So we're going to make a dictionary nested inside a dictionary. I believe my dictionaries right now are Webster, Webster 2, and Webster 3, if I remember correctly, or what I've defined so far. So I'm going to define a new dictionary, and I'm going to call this one Sam Johnson. And inside of this dictionary, the first one is going to be Merriam Webster. The second is going to be, Collins. That's going to be Webster 2. And the third is going to be Oxford, and I'll make that Webster 3. And now when I call Sam Johnson, tab for autocomplete, we get a much larger dictionary with a set of keys. Merriam, Collins. Notice the slight tabbing here indicates the superiority of some keys over other. Merriam, Collins, and Oxford were the three major keys. And then Merriam is short. Collins is a bit longer. It stretches all of that because it has a lot of keys with some nested strings. And then Oxford is the third. So when you have a deeply nested dictionary like this, how do you get to a single element, such as, parrots, for example? Well, let's see if we can call that out. First, we'd want to do Sam Johnson, and then Oxford. And then inside of Oxford, there's a key called animals. And then animals has a list, and I believe that parrots is element 2, and there we go. And if instead I wanted to get the number of parrots, And I would change animals to numbers, and we've got 22 parrots. And this nesting of elements within dictionaries is how most APIs are structured. That is to say, anytime that you're getting data from a website, a structured website, you're probably interfacing with a nested dictionary built out as an API. So a very common way of transferring information over the web. And this actually went a line below because this goes below this, so it would have gone there. And you can keep calling keys deeper and deeper until you find the individual element that you want. A few dictionary methods. So there are a few dictionaries methods you can call. Remember, a method is a built-in function in Python, such as when we had a string earlier, I don't know, my string is equal to string, right, lowercase letters here, right, and then we called my string upper, right. That's an example of a built-in method. So let's, on one of the dictionaries we've already got, such as Merriam. What was Merriam? Was it one? Well, that was part of Sam Johnson, that's why. Sam Johnson was a dictionary. If we want the keys in that, we simply call it the keys method. Merriam, Collins, Oxford. And since each of those was also its own dictionary, you can call Sam Johnson Merriam and get those keys inside of it. So the .keys method is a great way of getting to understand kind of what's inside of your nested set of dictionaries. Similarly, Sam Johnson .values lists all of the values but not the keys. And again, if we went to Merriam, drop that in there, you would get volume 1 and volume 2. I think I had another one in here called Oxford. And this is pretty frequent. .keys and .values and .index are kind of the big three ways of getting into a data structure. And a method to return the key value pairs of items as tuples, which is what the next lesson is about. Webster looked like this. Webster 2, I liked that one. Webster 2 items returns each of the keys with its value, but in a different format. Now it's in parentheses instead of being in curly brackets, which means that I can now do a whole bunch of other tuple methods on that thing. So keys, values, and then items pairs the two of them together. Okay, so hopefully that's a good kind of first step towards dictionaries. We have a very nicely structured exercise on building out dictionaries. But before I do that, I would like to talk a little bit about tuples first, and then we'll come back and do the structured exercise. And that's solutions. Let's get into lessons and tuples. Okay, so we've seen strings, we've seen lists, and we've seen dictionaries. Another less frequent but still important Python object is a tuple. And basically a tuple is a list, except that the items can never be rearranged. It's what's known as an immutable list. And when would we want to use that? Well, again, if you were working with some kind of database structure where you always needed the identifier, first name, last name in that order, and you never wanted first name, last name, and middle name to get switched around, that would be a good example of having a tuple because it's an ordered sequence that cannot be changed. So very similar to lists in a lot of ways. I'm going to talk about how to build them, what are some of their basic methods, immutability, that is to say the property of unchangeableness, and when you would want to use them. And as you can guess, you can stick a tuple inside of a dictionary and it works just fine. Okay, so we built a list as follows. Square brackets, 1, 2, blue, false, right? To build a tuple, I'm going to call my tuple turtle the tuple. It's exactly the same thing, all those same elements, but I put them in parentheses. Now when I call turtle, whoops, turtle, it'll give it back to me. So it looks very similar to a list in a lot of ways, and it can contain any object in it. It can, just as lists can, contain a second list. Thing 1, thing 2, I can also put that into my tuple. Just like a list, you can check the length. So the length of turtle is 5. There are 5 elements in it. And as I demonstrated above, you can certainly mix object types. Type turtle is a tuple. Turtle element 1 is an integer because it's 1. Turtle element 2 is a string. Element 3 is a Boolean. And element 4 is a list. And just as we did with indexing, turtle 3. So very similar to lists, you can use indexing to pull up individual elements. And you can also slice. So we had Franz, everything after 2, or we could reverse it, right? Remember all the slicing methods we used earlier? It's exactly the same with tuples. Turtle, oops, sorry, square brackets. Everything up to element 3, everything after element 3, reverse it using a -1. Basic tuple methods, like lists and strings, they have some built-in methods, but not quite as many of them. Franz.index, that was a, whoops. Index had a built-in element to it. And you could call the index of, I believe false was an element in there. And it would tell you what is the element, sorry, what is the index number of the element false. Remember that Franz looks like this. So if I ask it to tell me the index number of blue, that would be 2. And the index number of thing 1, thing 2 is index number 4. So it's exactly the same with tuples. Same thing with tuples. I'm just going to use my friendly find and replace to replace Franz with turtle. Replace all, save me a little bit of typing. And once again, we get the index of each of these as we pass them in. So for example, the index of element 1 is 0. You can use the .count method to count the number of times a value appears. So right now, every one of these occurs only once. So if I do turtle.count blue, it's going to appear once. But if I go back up here to where I first defined turtle, and I just add a whole bunch of blues to it, and I run that, and I scroll back down here to my count, now I count blue, tells me that blue appears 6 times. So immutability, lists can be changed. Franz looks like that. Franz element 2 is blue, and I would like to change that. So I say Franz element 2 is now orange. And when I call Franz, Franz has changed, right? So lists are mutable. They can be changed. That's not true with tuples. Not so with tuples. So I'm going to call back turtle element 2, and it's blue. And now I'd like to change that. Turtle element 2 is now orange, and I get an error message. Tuple object does not support item assignment. That is to say, you cannot reassign items. You also cannot reorder them or reverse them. So for example, a few nice list methods that don't work with tuples. And this is kind of a review of lists, right? We had Franz look like that. And we decided to say Franz order, sorry, sort. Doing this by memory, which I shouldn't do. That's right, because the reason sort is not working here is because we've got strings and integers in there, of course. If it was a series of Franz 2 of all numbers, of course it would work. And then you do Franz 2.sort. And now you call Franz 2. Franz 2 has been reordered, right? And we also saw the reverse one for that. None of that will work with tuples. Reverse was the other one we saw. As a result, tuples can't grow. Once a tuple is made, you can't add to it. The way you did add to lists using the append method, which is the other big one, Franz.append something new, right? And then you call Franz, and I've added to it using the .append method, but you cannot append to a tuple. So as it says at the bottom, you might be wondering, why would you bother using tuples when we have fewer available methods? So they aren't used quite as frequently, but as I mentioned earlier, for the purpose of data integrity, you would want to use a tuple to make sure that neither future you nor any other programmer on your team is able to accidentally mess up your pairing and ordering of data. Okay? So next up would be sets and booleans. 7:43. You guys want a 5-minute break? Take a second, stretch your legs, get some water. 5 minutes, come back.
You mentioned like best practices with capitalizing classes and such. With like spacing and lists, there should you include spaces if it's strings between items and not numbers, or does that make it matter?
The spacing does not matter, but it makes it easier for you to read it. What items are opposed to items.
Right.
Same thing when you have like equal sign.
Right. Is there, so there's no accepted standard spacing?
Not one that I'm aware of, but most people's code that I look at is readable because remember, of course, the space is kind of a big no-no. Is in when we get into data structure called arrays, which I think you're showing. You can put spaces in version names, but it's usually the best practice not to. They do at the front desk if you're willing to make the trek all the way down those stairs.
Again.
Yeah. Quick poll in Slack. Let me know how it's going. All right, so we're going to dive back into sets and booleans. And this is the last thing that I want to cover tonight. The other three lessons are nice to haves. This one is about how to open and close text files in Python. A nice to have, but not something that you use very much, because what you really open and close a lot is CSV files, and that's going to come a little later on. And comparison operators is basically greater than, less than, equal to, pretty straightforward stuff. But sets and booleans is definitely big, and then we're going to get into two kind of hands-on assessments. So a set and a boolean, these are the last two big Python structures. We've seen numbers, strings, lists, dictionaries, tuples, and now we'll see sets and booleans, which are the last two. Sets are very similar to lists, except that they contain only unique elements. If you remember, when we defined Franz as blue, yellow, red, and then we did Franz.append blue and print Franz, then it had those elements. But every time I run this cell, oh, because it redefines, right? Let's do this separately. Run that one. Whoops. Put that one there. Now every time I run this cell, Franz will get a little bit longer, right? So clearly, it's not a problem for a list to have repetitive elements. This is not true with sets. They can only have unique elements. Define a set. Irish setter is going to be the name of my set. And I define it as an empty set called set with parentheses. So the syntax here is something that we haven't seen before. It's green. It's what do you call it, a Python method. There are actually a few of these, by the way. Quick aside, a few Python methods. You can call this mylist is equal to list mylist, right? And now that helped me define an empty list. And we can do the same thing with Miriam as a dictionary, and then I call Miriam, and it's an empty dictionary. So each of these, set, list, and dict, is a built-in Python method for establishing an empty object of that type, and then you can add things to it. So you can do mylist.append stuff, and then print mylist, and now it has stuff in it, right? So the same thing happens with defining a set. I've defined an empty set called Irish setter. And now I'd like to add a few things to Irish setter. So Irish setter dot add 1 and call print. And it comes back kind of looking like a dictionary because it's got curly brackets, but not like a dictionary because it doesn't have any key value pairs. And now I'm going to add 2 to it. And it's got that. And I'm going to add 3 to it. Curiously, it's done that, but it's got them out of order. Now let's try adding a Boolean. It won't allow me to do that. It only likes strings and numbers. So far, so good. But now I'm going to try adding 4 a few more times. No dice. No dice again. It doesn't give me an error message. It simply doesn't add it. But if I change it to 5, it is going to add that. And this, of course, is just the same.
You can't have 2 of the same name, correct?
Exactly. Sets must always have unique elements, and if you try and duplicate an element, it doesn't error out. It simply doesn't do what you asked it to. It stays put. So sets are always unique. And as the note says, note the curly brackets, not a dictionary. It's kind of like a dictionary of keys with no values. And this is an example of what I did earlier, right? It's more of the same stuff. Trying to add the same element, I did that. Won't place another one. Only can have unique. So create a list with repeats, which was Franz has a whole bunch of uniques. And here's the fun part. Suppose you'd like to know, right? How many unique elements are in my list, right? Maybe you're wondering that. Maybe like, I know there's a bunch of colors in there, but how many unique colors are there? Well, I'll just go set Franz, and it will tell you that. There's only 3 unique colors in there. Set of any list will give you the unique elements in that list. So a really powerful method to quickly flush out all the unnecessary stuff and keep only the wheat. Get rid of the chaff, keep the wheat. That's it about sets. Booleans, and I don't actually know where that comes from. It's probably named after somebody because it's a capital B. Probably a good guess.
I think it was cool.
Do you know who Boole was?
No.
Oh, I don't either, but I'm sure that's that. He's at least nothing else has given us his name, or maybe it was a she has given us her name. So Python comes with Booleans, which are clearly just true or false. Those are only your options, and they're basically displayed like the integers 1 and 0. You can even add them up.
George.
George Boole? Okay.
Absolutely.
So, so let's have a Boolean. We're going to call this George. George is the name of our Boolean in honor of. But of course, we have to use lowercase letters because that's best practice. It's not a class. And George is equal to true. And now when I call George, it gives me back the value true. You can also use comparison operators to create Booleans. So is 1 greater than 3? Well, no, it's not. That's false. So let's call George, let's call it Martha. Martha is equal to 1 greater than 3, and now when I call Martha, Martha is always false. Or George is equal to 42 equal to 42, and then call George, and that's true because that's a true statement. Pretty sure this will work. Is 2. Martha is -1. So you can actually do arithmetic with Booleans because they're treated as zeros and ones if false or true. And you can use none as a placeholder, none as sort of a pseudo Boolean, right? For an object that we don't want to reassign yet. So I don't know, George, Martha, let's call Abe while we're in this, right? It's none. Abe is it. And Abe gives nothing back, right? When you call Abe, it doesn't give you the word none, but it also doesn't give an error response. Abe is just a placeholder. And again, I don't think this will work, but yeah, I was figuring. You can't, it's not actually a 0. Martha's a 0, George is not. Okay, so that's pretty much it for sets and Booleans. Questions or comments about that? Okay, so we've got 2 assessments and about 33 minutes to get through them. The first I'll walk through together, and the second I'll turn you loose to try on your own. So I'm back up here at the highest level folder under assessments. Digging into here, we have dictionary practice, and we have assessment test and assessment test solution. I'm going to start with dictionary practice, which is an exercise on building out a city dictionary. I'm just going to walk through the solution and then have you write your own similar to this. The exercise here is to try creating your own dictionary. So we start with the dictionary, we name it, let me go full screen here. We name it cities, we set it blank. Anybody remember the other way to create a blank dictionary? Just the DIC parentheses command would do the same thing. We give it a key called Europe, which is an empty list. And then we use a for loop. This is the first time that we actually see a for loop in the course, though I know a number of you have already been kind of slacking them out in your pseudo code. Here's a list of cities, and for every city in that list, append that city to my dictionary of cities, and now Europe has the following list in it. That's the first key value pair of my dictionary called cities. The second key is USA. We start with a blank dictionary. So it's a dictionary of dictionaries. And here I'm not going to use a for loop. Instead, I'm going to give a series of keys, New York, DC, and Chicago, and each of those is its own dictionary. So now I've got a dictionary nested in a dictionary nested in a third dictionary. And for my USA cities, now again, you could have done this with a for loop, but I'm just going to spell it out. Key, dictionary, key, key, key is equal to the following list of values. And each time I use the same key landmarks. I don't have to, but I choose to do that because I wanted to have a consistent key in each city. At this point, what does our dictionary look like? Well, we've got Europe, which is short. And we've got USA, which is a bit longer because it has 3 cities, each of which has a set of landmarks that's 3 elements long. We're going to build up that USA dictionary even longer. We're going to give each city a second key called food, the famous food from that city. And then a third key, numbers, which is a set of parentheses. What is that? What do parentheses indicate? Tuples, exactly. So an immutable number string pair to make sure that every number is always associated with its appropriate person. And the finished product looks like this. Europe is short, USA is long, it's 3 cities, each city has a set of landmarks, a set of numbers, and a famous food. Down near the bottom, I can call those keys. So the 2 major keys of my dictionary are Europe and USA. Within Europe, I look at the first 3 out of 4 possible, so that's list indexing. I can take my American keys and turn them into a list. And likewise, I can take my Chicago keys and turn those into a list. And then calling dictionary, key, 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 I get the following value. Likewise for New York City. And finally, I use a for loop to list out those elements one by one. So the next task is to build out your own dictionary similar to this. Let's take 15 minutes for that. When you're done, post something like this into Slack so we can see what you've built out. Use this notebook as a template. Go for it.